Hi everyone, my name is Dr. Brooke Johnson and I'm a geologist. I work here at the University of Liège in Belgium, where I study rocks and fossils that are billions of years old. But I'm originally from Teesside and I started collecting rocks and fossils on Redcar Beach. I always wanted to know why the shells in the rocks were made of stone and why they were different from the shells on the beach that got washed up by the sea. That's because the rocks on Redcar Beach are nearly 200 million years old, from a period we call the early Jurassic. Back then, Teesside was mostly underwater and the beach was all the way inland near Northallerton. It was a lot warmer back then too. The land was covered in jungles full of dinosaurs and the sea was full of strange creatures like these ammonites and devil's toenails.
So how do we know where the land used to be, and how do we know that it was a tropical climate? Well, there's a couple of different ways that we can tell this. The easy way to tell it is as you go to the west towards Northallerton, there's more and more sand and less mud in the rocks. And generally that means you're getting closer to land because the sand comes from the land. And as the water gets shallower, you get more and more shallow water sedimentary structures like fossilized wave ripples. And we can see that the sediment was getting churned up by waves on a daily basis. So that means you're getting shallower and closer to the land. Eventually, as you get towards Northallerton, the Jurassic rocks get thinner and thinner and are completely eroded away. And that's because in the shallowest water up by the beach, you don't get deposition of the sediments. You actually get erosion of them because they're getting carried out to sea and dumped on around about Redcar. Another way we can tell we were close to land and that land had tropical forests is that we get lots of this fossil wood at Redcar Rocks. And it's a type of fossilized tree that lived in tropical conditions, so we know that the land was tropical. This also tells us that the land was nearby, because to have this much fossil wood, you have to be relatively close to land, because even though wood floats and drifts out to sea, it eventually soaks up the water, becomes heavy, and then sinks and gets degraded and buried and fossilized. Looking at this bit of fossil wood from Redcar Beach, you can see the difference between the Jurassic fossil wood, which has been completely mineralized and turned to stone basically, and you can compare that to the other fossil forest, which is only a few thousand years old, and see how that's still made of wood, but this Jurassic stuff has been completely replaced by minerals and then by mineralized carbon as well, which is the black stuff.
The Pennine Mountains were a lot bigger back then as well, and there were big rivers that came down from the northwest and dumped loads of mud out into the sea. Sometimes big tropical storms would stir up all of that mud and bury creatures that were living on the seabed. The hard parts of the animals, like the bones and the shells, had turned to stone, but the soft parts had all rot away.
So how do we know that there were big storms back then? Well, there's a couple of ways. Firstly, because we know ancient environments operate the same way that modern environments do. The other way is that storms leave traces in the rocks, and we can see lots of those traces on Redcar Rocks. If we look at this photo here, we can see you've got that dark grey layer in the middle, and that's the clay, and that's the fine-grained sediment that was getting deposited during everyday deposition for most of the year. And then you've got that layer at the top which is full of shells, and that's made of limestone and sand and bits of land plants, and that's a storm deposit, and we call those a tempestite. And that's where there's been a big storm, you've had probably flooding on land, lots of material gets washed off the land, the seabed gets picked up and churned around, and it all gets dumped down really quickly, all of the shells that were picked up and all of the sand and bits of plants and whatnot that have come off the land. And that's one of the reasons why there are so many fossils here, because a lot of the time, a lot of the stuff on the seabed would be just picked up and then buried immediately and couldn't escape.
And that's one of the reasons why Redcar Rocks are so full of fossils. In fact, Redcar Beach has some of the best early Jurassic rocks and fossils of anywhere in the world.
Another way that we can tell that we were relatively close to land and in a tropical environment is all of this red material, like in this rock we've got here, and that red stuff is iron oxide. And all of that iron is getting leached off the land by something called lateritic weathering, and that's where you have a hot dry season and then a hot wet season. And when you alternate between these two types of season, all of the iron gets oxidized really quickly and then extracted and weathered from the rocks. Then that gets mixed up with organic matter, all those bits of plant that we saw, and then transported into rivers, and then the rivers transport it out to sea. These fossil bits in this bit of ironstone, which is what this is called, are something called a crinoid, and that's kind of like a starfish on a stalk. It looks like a plant, but it's actually an animal. And then there's one last bit of evidence that shows us that we had warm tropical conditions, and that's the microscopic fossils that we find in the mud when we look at it under a microscope. So these images here are some of Redcar Rocks that I've sliced up really small, and we're looking at them under a microscope. And all of these holes here that we're looking at is actually a tiny fossil coral. We know that corals like to live in tropical regions, so we know that Redcar was tropical back then, so another bit of evidence. And then we've got all of this green stuff with this bobbly texture. And believe it or not, that's iron, and that's a mineral called glauconite, which is an iron clay. And the reason it's got a bobbly texture is because it's replacing the shell of a sea urchin. And that tells us that in the sediment, the oxygen level was going up and down quite a lot, because iron oxide obviously needs oxygen to grow, but glauconite also needs a little bit of oxygen to grow, but not too much. And one of the ways that you can make the oxygen level on the seabed fluctuate is by having really warm water, because warm water holds less dissolved oxygen than cold water.
But wait, there's more. If you look at them from above, you can see that Redcar Rocks are folded into a dome shape, and that's because 60 million years ago, Africa collided with southern Europe and started to fold up all of those rocks. The biggest folds from this collision are called the Alpine Mountains, but smaller folds reached all the way up to Redcar, and that's what's folding Redcar Rocks into the shape that they are. But that's not all. About 100,000 years ago, there was an ice age. Big floes of ice called glaciers slithered across the land, bringing chunks of rock from faraway exotic places like Scotland and Scandinavia. When the glaciers melted 10,000 years ago, mud and those rocks got dumped onto Redcar Beach, burying an ancient forest. You can still see the remains of that forest near the vertical pier. The glacial till is still there too, covering up the Jurassic rocks, and at the east end of the beach it forms the cliffs between Mask and Redcar. You can still find all of those bits of rocks and fossils in the till that were brought by the glaciers. And if you're really lucky, you can find bits of exotic metamorphic rocks from Scotland and Scandinavia that are billions of years old. These are just some of the reasons why Redcar Beach is so special. Not only can you walk through 200 million years of the Earth's history, but you can also get a bag of chips and an ice cream. Just watch out for the flying dinosaurs.